We're on 4.4, trigonometric functions of any angle. And I can't stress enough, when it says any angle, we need to remember this. And what I'm saying there is not all angles are on a unit circle. Okay, that's where this is going to change some. Okay, so not all angles are on the unit circle. Keep that in mind because that's going to be huge in what we need to do here. Okay, so think about my triangles. Okay, and I can't stress enough. I know I said this a lot when we were working with the unit circle, but I'm going to say this again. All triangles are from the x-axis. Okay, so that is not going to change. Anytime you draw a triangle, no matter what quadrant you're in, first, second, third, or fourth, you draw using the x-axis as one of the legs, okay? So you kind of come into your quadrant, you go from here, you bring up, and your triangle is somewhere here, okay? You always use the x-axis. So that's my x value, here's my y value. The big difference is now, because we're not on the unit circle, I have an r value, okay? Earlier, r was 1, and we know when we simplify anything with 1, it just kind of disappears, so we didn't worry about it. But now it's there. So when you look at your sine, cosines, tangent, these have not changed. We just earlier replaced all the r's with 1, and so it simplified out and looked a little nicer. But that doesn't mean it's different. Okay, a couple things we want to think about with these triangles, okay? They're often going to give you an ordered pair, x, y, which means you don't have the r, okay? Well, think about your Pythagorean theorem. X squared plus y squared equals r squared. So if I want just the r, I would take the big square root of x squared plus y squared. Okay, that's how I find r. So when you see this note up here, how to find r, it makes sense. It's just coming off the Pythagorean theorem, okay? So the key on these is do not assume that your hypotenuse is 1, and because of that, we now need to do sine is y over r, not just y. Cosine is x over r, not just x, okay? And to be honest, everything from there, once you were real careful on the sine and cosine, everything else is going to be found the exact same way as before, okay? As long as you did the reciprocal parts. So let's look at our first one. We're given the point -2,5, and we want all the exact values for each of the 6 trigonometric functions, okay? So when we talk about the 6, we're talking sine, cosine, tangent, cosecant, secant, and cotangent. Where is -2, -5 at? What quadrant? It should be in the 3rd quadrant, right? So I have my little, here, my little chart, and I'm going to make it go -2, -5. So when I go -2, -5, I'm here, and my triangle always goes off of the x-axis, okay? My angle I want will always be coming from the origin, okay? That's where your angle always is. So the angle is always at the origin. I should do that. All triangles from the x-axis, the angle is from the origin. Okay, because every now and then we get confused. We always get this right angle on the other side, and then I have this angle, and I just made my picture look terrible. I think I've done too many videos in a row, to be honest. Okay. Okay, so from my x-axis, I went 2, then I went down 5. I'm coming off of this theta, and I have a right angle right over here. Okay, that's where we're at. A little better. So I went left 2, I went down 5. Okay, I'm going to be honest. Notice I did not put signs on there, okay? Now, you can, though. So you can put -2 and -5. We just have to make sure we're careful with those. They give us direction, okay, and they're going to help us in our sine and cosine. So, but if you think about getting the radius now, because we need that r, we're just doing Pythagorean theorem. The negatives will kind of cancel, right? So r is going to be, I'm trying to think where I want to put this so I have enough space. R is going to be the square root of x squared plus y squared, okay? So if you can handle doing a little math in your head, x squared is, x is -2, squared is 4. Y is -5, squared is 25. 4 plus 25 is the square root of 29. Okay, don't touch it. Don't do anything else right now. There, it doesn't simplify, just leave the square root of 29. Okay, so my sine of theta. So I go to my angle, and I want, oops, I should put this over here. I want opposite over hypotenuse. So opposite that is -5. And actually the negative is nice because sine in that third quadrant is negative. So if I left that negative there, I see it over the square root of 29. Can I leave that for my answer? No, because I have to rationalize it, which means I'm going to multiply by square root of 29 over square root of 29, which is going to give me -5 square root of 29 over 29. Okay, so cosine. Same angle, adjacent over hypotenuse. Adjacent to that angle is -2. I'm going to keep the negative on it because cosines in the third quadrant are negative. Hypotenuse is square root of 29. I need to rationalize. I get -2 square root of 29 over 29. And finally, my tangent of theta is going to be, opposite over hypotenuse, -5. I keep saying that for tangent. Opposite over adjacent, -5 over -2, which is going to simplify to 5 over 2, right? Both positive now. Which tangent in the third quadrant is positive? All right, when I go to do my other ones, cosecant. I'm glad that I left, and I should say cosecant of theta. I'm glad that I left this here because now when I do the reciprocal, it's just that flipped, right? Square root of 29 over -5. Sometimes when I rationalize, it's harder to flip it back the other way. Secant is just going to be my cosine flipped, and again, I like the square root of 29 over -2. And my cotangent there is going to be my 5 over 2 flipped, which makes it 2 over 5. Okay? Use Pythagorean theorem to find your radius or your hypotenuse, however you want to think about it, and then use the three values to find your sine, cosine, tangent, cosecant, secant, and cotangent. Okay, example B here. It says, given 3 pi over 2, just 3 pi over 2. Find the exact values of your 6 trigonometric functions. Okay, so go back to think about your unit circle, right? Where is 3 pi over 2? Okay, well, 3 pi over 2 is right here, right? I know I said we're not on the unit circle, but you can be if that's all they tell you. So 3 pi over 2. It has this ordered pair down here of 0, -1. All right, so let's find our values. Sine. I'm going to just do theta because we can. Sine of theta. That's my y value, right? Over 1, because right now my radius is 1 because I'm on the unit circle, so it's just my y. It's going to be -1. Cosine of theta is going to be the x value, which is 0. Tangent of theta. Now remember, tangent is sine over cosine, or y over x. So that'd be like -1 over 0, because there's no angle that I can even see there, even though 3 pi over 2 is an angle. It's right there on the line, right? There's just no triangle. And my tangent is undefined. So my cosecant is going to be my -1 flipped, which is just -1. My secant is going to be that 0 flipped. When I flip it, it becomes a 0 in the denominator, which is not good, and that one is undefined. And when I flip my tangent for cotangent, I get 0 over -1 now, and I'm allowed to have that, and my cotangent is 0. Okay, so I used my value on my unit circle there. Because the rule is still the same, it's just on the unit circle, we shortcut because the radius is 1, we just kind of ignore it. But it can use this same rule. So when in doubt, just pretend nothing's on the unit circle and find its radius, and then you'll still get the correct values. All right, a study tip on the bottom. I'm going to be telling you, I've been holding out on you guys, because when we did the unit circle, this might have been a nice, good study tip to do then, but I waited because I knew it was coming up, okay? So it says, remember how I told you, if you can remember the first quadrant of all your sine, cosine, tangent values on your unit circle, then all you need to know is the signs, okay? So this is this textbook, this is their study guide, their study tip for how you remember that, what signs go where. So think about your 4 corners, okay, on your unit circle. I have sine, cosine, tangent. I have sine, cosine, tangent. I have sine, cosine, tangent. And I have sine, cosine, tangent, okay? Obviously, like their secants and cotangents go with them, but I'm really worried about these. Okay, how do I remember which signs go where? Okay, here's the easiest thing. A, smart trig class, because that's what you guys all are, right? A smart trig class, okay? When we do that, it goes around the circle like this, okay? A smart trig class. A means all, okay? So all of these are positive, okay? Smart, that's a sign. For S is sign, so only the sign is positive. The other two are negative. The next one, so A smart, we're at trig. That goes to T. So the T is positive, the rest are negative. And then class. So the class goes with cosine, so the cosine is positive and the rest are negative, okay? So if you think of A smart trig class, that's where you put the positives. All, sine, tangent, cosine. A smart trig class. Or you just memorize them. Think about what gets the x's and the y's. You know, there's multiple ways. This is just a study tip. You don't have to memorize it. I'm going to admit I use it all the time. But anyways, all right. For example C, find the exact value of each of the remaining trig functions given that the cosecant of theta equals -4 and the tangent of theta is greater than 0. What is this even saying? And by the way, gave you a delta math assignment, and you have some of these on there because the more you practice them, the better you get at it, and it's not so scary when you see these directions, okay? The cosecant of theta is -4, and the tangent of theta is greater than 0. Okay, here's what you need to start with on a problem like this. Where are we on our coordinate plane? That is the key to starting these problems. So start with simple signs. Cosecant is negative. The tangent is bigger than 0, so the tangent is positive. In which quadrant do we have a positive tangent and a negative cosecant? Or, in my thought bubble, it's not cosecant, it's sine, right? Where is my sine negative, but my tangent positive? Sine negative, tangent positive. Well, it looks like I've got to be in that third quadrant, okay? That's what all that's saying to start with. Okay, so here's the deal. I had to figure that out first. Here's my triangle. I'm just going to draw it, okay? Because I had to figure out that. That's why they tell me, and of course I covered it up here, that's why they tell me that the tangent is bigger than 0. It's positive. That's all that's telling me. And from the cosecant, I know my sine is negative, okay? So that's where I need to know what quadrant it is. Okay, the other thing I need to know is the cosecant is not just -4, because cosecant is the flip of sine, right? So if I want to flip it, I need it to be a fraction. So put it over 1. So now when I flip sine, I'm going to be 1/4, okay? Or the negative somewhere on there. Does that make sense? You got to be able to take that and you've got to be able to flip it. Okay, so I go to theta, and this 1 and 4 is my opposite and my hypotenuse. So from my theta, opposite must be 1, and my hypotenuse must be 4. You see, I just take those values and I break them apart and make an opposite and a hypotenuse, okay? I'm missing one of the sides. How do I find it? Mr. Pythagorean. All right, which one's my C? It's 4. 1, and we'll call this one over here x, right? 1 squared is 1, x squared is x squared, 4 squared is 16, subtract the 1, x squared is 15, and take the square root. And there's no pretty or anything, so I'm just going to leave it the square root of 15 and label my triangle. Okay. Remember, not on the unit circle because my radius isn't 1, but that's okay. I can still find all my values. Okay, so here we go. Sine of my theta. Well, I already knew it was 1/4, -1/4, right? Cosine of my theta. I can either use the picture, which is probably the easiest, right? I go to my theta and I go adjacent over hypotenuse, so I get square root of 15/4. Quick question here. I'm in the third quadrant. Is that positive or negative? Negative. And in fact, what I probably should do is just put a negative on my 1 and a negative on my 15, square root of 15, and it'll help keep me on track for my signs. Tangent of theta. Well, I can either look at my picture and go opposite over tangent is opposite over adjacent. One of these days I'm going to say it correctly. Or I can do my sine over cosine, either way you want to think about it. But so I get -1 over negative square root of 15. I know I can't leave it that way, so I rationalize. And they're going to be positive because of the two negatives. I get the square root of 15/15. All right, my cosecant, I actually started with, right, was -4. You can put -4, you can put -4/1. I wouldn't mark off for that. My secant is going to be my cosine flipped, and it looks like I'm going to have to rationalize. So how about -4 radical 15? Oh, I'm off too far on this side. See if I can squeeze this in here. -4 square root of 15 over 15. Okay, with the rationalizing. And my cotangent is going to be, look back at before I rationalize that, and I just flip it, and it's going to be the square root of 15, and it's positive. Okay, let me make sure I have my negative. So cosecant is negative, and secant here is negative, right? Okay. It's good to practice these because our brain freezes when we get there, like, what do we know? And remember, that tangent part up there, all this does is helps us with our quadrant, and so did that negative right there. Those two pieces helped me find my quadrant, so I knew where to draw my picture. Then I go back to just the cosecant to get values to put on my triangle, and then I can find my missing side and find my all my trig functions from there. Okay, second page of our notes. I must say, for only having 2 pages of notes on some of these days, we're packing a lot of information in on these, okay? All right, definition of a reference angle. Let theta be a non-acute angle in a standard position that lies in a quadrant, and its reference angle is the positive acute angle formed by the terminal side of theta and the x-axis. Got that? Make sense? Okay, couple things I want to stress on this reference angle. We don't use it as much now as we're going to use it in the future, okay? There will be a day when I'll say, this is why you really need to know your reference angles. We're not going to use it enough right now to even make it seem important. I'm just going to state that right now. But it's just like those cofunctions we did the other day that I told you you're going to forget about. There's a chance you're going to forget about this reference angle too. But if you can go back to these notes about these reference angles, this is going to be important, okay? The key to a reference angle is going back to that thought of, if I could just keep all my values in the first quadrant and know the values in the first quadrant, all I need to do is change them with a sign to go from there, okay? So, and then I can use all the same values. So in my reference angle, this is what you need to remember. If you think about the coordinate plane, okay, and you think about the property that I've said before over and over and over, every triangle we draw needs to come from the x-axis, okay? So this is the angle. So over here, this is the angle from the x-axis. So down here, this is the angle. Down here, this is the angle, okay? So the angle of wherever I'm at comes off of that x-axis, okay? So when I'm in the first quadrant, it's super easy because wherever I'm at coming off my circle, whatever I need, that's just my angle. So if I'm in the first quadrant to start with, the angle is the angle. It's fine, okay? To get the reference angle in the second quadrant, I'm coming off the x-axis, so I'm going to do 180 minus the angle of wherever I'm at in that quadrant. So if I have an angle of, let's say, I need to be in there. Let's say 110, I would do 180 minus 110, and I'd have a reference angle of 70, okay? So on the third quadrant, I'm taking 180 and adding whatever angle I am. So I am 180 plus my angle, okay? Plus my angle in that, okay? And by the way, what I'm saying right here is right here written out in words as well. So in the fourth quadrant, I'm coming off the x-axis, so it's going to be 360 minus my angle, okay? And again, it's written right here. So it's not like I don't have it in multiple forms, but that's really what we're coming from. A reference angle is how far are you from your x-axis. And if you always keep that where you're at and you do that simple multiplication, you're always going to get an answer that's between 0 and 90 degrees. Or if you're in radians, between 0 and pi over 2, okay? Let me tell you, this is where in PreCalc you start saying, man, why do we work in degrees? It would be so much easier if everything was in my reference angle, okay? Was in radians, okay. So here we go. I have 315 degrees. What's its reference angle? Well, 315, that would be in quadrant 4, right? And I'm going to just kind of start labeling these so I remember quadrant 4. Don't ask me why the Q's in there, in the bars. It's been a long day. So in the fourth one, I'm going to do 360 minus 315, and it looks like my reference angle is 45 degrees, okay, which is great. So on my unit circle, I can go from there. Okay, here's where we really want it. 2 pi over 3. I don't care which radians you're in, it's the denominator. Pi over 3, done. I don't even have to worry about subtracting or doing anything else. When you're in radians, it's simply the denominator, okay? Notice, I didn't even point it out, but I should. The any angle in radians has a reference angle of the same denominator. Just note what quadrant it's going to be in, so I probably should go back, okay? 2 pi over 3, it's less than 1, so it looks like I'm going to be in quadrant 2, right? Because I just need to know later for my signs, right? All right, negative 315. Okay, for one thing, that's going clockwise. I don't like to go clockwise, so the very first thing I'm going to do is just add 360 so I can figure out where I am in a positive. So I'm at 225, okay? 225 is in quadrant 3, right? And so what I'm doing in quadrant 3 is I just take my angle is already big, right? 225. So what I need to do, and I need to be able to, I didn't stress this very good, it's the angle minus 180 because I want to figure out how far away I am from the line. So it's the angle minus 180. I'm sorry, I did not explain that well earlier. And it looks like I'm back to 45 degrees. So 45 is where I'm going to get the values from, and then I have to think I'm in quadrant 3, so what sign goes with them? 3.6. Where's 3.6? What is 3.6? I don't have any markings on this. There's no label, and anything that's unlabeled is an assumed radiance, okay? So stop and think. 0 to pi. Pi is about 3.14, okay? 2 pi, which is the full radius around the circle, is 6.28, right? So if I'm at 3.6, I am in quadrant what? I need to figure out what's 3 pi over 2, right? So 3 pi divided by 2 is 4.7. So it looks like I'm definitely in quadrant 3, right? So make sure we know what quadrant we're in. So we're in quadrant 3. And so I'm going to just do the angle, which I have is 3.6, right? Minus 180, which is my 3.14, okay? Or minus pi, right? So I just do 3.6 minus pi, and I get about 0.458, okay? I guess I don't have anything in the directions as far as how to do it. I'm going to leave it 0.46. I would not round to the nearest tenth because it doesn't get specific enough. If you think about between 3.14 and 6.28, there's not a lot of numbers between there, so the decimal places are going to hold some good value there. Okay, we're going to keep going on these. 650, too big, so I'm going to subtract 360, and that takes me down to 290. So now I know that 290, I'm in the quadrant, what's more than 270, so I'm in the fourth quadrant, right? Okay, so I'm going to do 360 minus my 290, and my reference angle is 70 degrees. All right, 15 pi over 4. I already know my reference angle in the back of my head, but first I need to figure out which quadrant I'm in, or I'm sorry, yeah, which quadrant I'm in. 15 pi over 4. So let's see. 8 pi over 4 is around the circle once. So if I go another pi over 4, so like 4 pi over 4, that's 12 pi over 4, that's there. 15 pi over 4, I'm just shy of 16 pi over 4, so I'm in the fourth quadrant. I don't know if you followed my ramblings there or not. So at least that tells me what signs I'm going to do, but my reference angle has to be pi over 4, okay? Again, we wish everything was in radians. So on negative 11 pi over 3, I'm going backwards around the circle, or what I do is I can add pi over 3, or 2 pi over, 2 pi, which is 6 pi over 3, right? I'm going to add it 2 times. That's 12 pi over 3, which will give me just pi over 3. Well, that makes it easy. Pi over 3 is going to be my reference angle, and I know I'm in quadrant 1 as well. All right, last one, 475. So I'm going to add 360 when I add 360, I'm still at negative 115. So I'm going to add 360 again, and I'm at 245. Well, what quadrant is 245 in? 245 is going to be in quadrant 3. So in quadrant 3, I take my angle and I subtract 180. Now that I fixed my note on that, and it looks like my reference angle is going to be 65 degrees. Okay. All right, reference angles. It allows you to go back and just work in the first quadrant and then attach the signs needed from a smart trig class, right? All right, use reference angles to find the exact value of each expression. Okay, so the first one is tangent of 420. Okay, first things first, I'm going to subtract to get down into I get tangent of 60 degrees. Because remember, a full circle won't change anything. Now, do I need a reference angle? No, because I'm already in the first quadrant. I can go to my handy-dandy unit circle, and at 60 degrees, my tangent is radical 3. Okay, I got that off my chart, or you can use your ordered pair and do sine over cosine, either way. Okay, secant of 13 pi over 4. So really all I need to know is what quadrant is that going to be in. By the way, if I do 13 pi over 4, 13 divided by 4 goes in 12 times, right? 3.3, it's like 3 and then pi over 4. Does that make sense? Okay, so 3 pi would take us to the 180 line. Pi over 4 will be in the fourth quadrant. So quadrant 3. I messed up how I said that. So we're in quadrant 3. Okay, I'm going to not think secant, right? I'm going to think cosine of pi over 4, because what's nice and easy to know is whatever's left here, whatever my decimal is, that's my reference angle. So I'm thinking cosine of pi over 4. Well, the cosine of any pi over 4 is radical 2 over 2. And because I'm doing secant, I need to flip. All right, and so that's going to give me 2 over radical 2. When I rationalize, I'm going to get 2 radical 2 over 2. My 2's cancel, I get radical 2. The only thing I need to go with is, in my third quadrant, is my cosine or my secant positive or negative? It's negative in my third quadrant, so I get negative radical 2. All right, sine of 17 pi over 3. Okay, I'm going to bring that negative out front so I don't have to worry about it. Sine of 17 pi over 3. Okay, I already know that I'm just going to be using pi over 3 as my reference angle, right? The only other thing I need to know is what quadrant is 17 pi over 3 in, so I know what sign I need at the end, okay? So 17 pi over 3. 17 divided by 3 is 5, and I'm left with 2/3. Okay, so 5 pi, that's odd, so that would be at the 180 mark. And another 2 pi over 3 will take me into quadrant 4. Okay, I know this is really hard without showing you with my hands. So if you're not sure how to do that, don't be afraid to ask me the next time we do a meet or something so you can see me do that with my hands. So in quadrant 4, all right, so let's see. My sine of pi over 3 is, any pi over 3s, their sign is radical 3 over 2. Because I'm in the fourth quadrant, my sign is negative, but I had a negative out there because of the odd function, so those are going to become positive. So my final answer is radical 3 over 2. Got to know your signs and your quadrants. You got to know your reference angles to make sure you're in the right thing, okay? All right, last one. Find the exact value of the expression and write your answer as a single fraction. Okay, I'm going to do a little activity here first to make this easier. All I'm going to do right now is list what quadrant everything's in. 11 pi over 4. So 12 pi over 4 would be 3 pi, right, which would be right at the 180 mark. So I'm going to say this is quadrant 2 because I'm just shy of that, right? 5 pi over 6. Well, that's on my unit circle. 5 pi over 6, that's in the second quadrant, right? Cosine of pi over 4, or 11 pi over 4. That's still that same as the other one, so that's also in quadrant 2. and 5 pi over 6 again. Everything's in quadrant 2. Great to know. Because to be honest, I don't even care what the top numbers are anymore, because I'm looking and I am thinking simply sine of pi over 4, because that's its reference angle, cosine of pi over 6, because that's its reference angle, cosine of pi over 4, because that's its reference angle, and sine of pi over 6, because that's its reference angle, okay? So the only thing I have to worry about is in the quadrant, is when things are negative or something. Okay, sine of pi over 6. I look at pi over 6, its sine is always 1/2. Notice these first two are side by side, which means I'm multiplying. Cosine of pi over 6 is going to be radical 3. I did that wrong, didn't I? By the way, pi over 6. It is my first order pair, radical 3 over 2 and 1/2, right? What else do I have? Pi over 4. Pi over 4 is radical 2 over 2 and radical 2 over 2. Okay, let me get the correct value here. Sine of pi over 6. I had that right, didn't I? Okay, never mind. Don't. Oh, thank you. That is what my problem is. It's pi over 4. I can't read my writing. Okay, pi over 4. The sine is radical 2 over 2. Cosine of pi over 6. There we go. Cosine of pi over 6 is radical 3 over 2. Cosine of pi over 4 is radical 2 over 2. Sine of pi over 6. There's my 1/2 finally. Okay. Now, in the second quadrant, sine sine is positive. So this is positive, cosine is negative, cosine is negative, sine is positive. All right, I think we're good to go. Multiply and then add. Radical 2 times radical 3 is the square root of 6, and 2 times 2 on the bottom is 4, because we're multiplying. I can't simplify that. Nothing comes out of 6. On the right side, radical 2 times 1 on top is just radical 2. 2 times 2 is 4. And I had this little negative out here, so it means it's negative. And I have common denominators, so I can join, but I just get negative square root of 6 minus the square root of 2 all over 4. And that does not come off a calculator. Let me tell you that right now, okay? So make sure you are just plugging in your values and doing the math that you can without a calculator. All right, got to use that unit circle. I realize more and more as I go through these notes with you right now, how much just being able to talk about these every day in class together to do a journal question stuff, it just helps it solidify and sink in a little bit more. Sometimes these notes seem very scattered and like, oh, here's a concept, oh, here's a concept, and keep it in mind. They all do gel together, but they don't always flow together very well. Okay? Practice on page 513, 3 through 102 by 3s. Practice on delta math. Delta math is really helpful, as if you're not getting it, it'll explain it to you. Read those explanations, figure out what's going on. There's 2 delta math assignments. I kind of waited to give them to you till we were finished with the notes, because part of it's coterminal, but then it goes with reference angle. So it kind of waited till these notes. And then some of it is just working on the unit circle itself and the triangles that come from it. So practice them, and then we're ready for some quiz practice as well. Let me know if you have questions.